Ramanujan for G is now available on the Google Play Store. Try it out for free.
Good morning, everyone. Okay, so today we'll see the binomial coefficients and their properties. Okay, so wait for a minute. Let me connect my writer to this. Yeah, so as we've seen, first let me write the topic name. Okay, so this is your binomial coefficient and their properties. Okay, so in the expansion of this 1 plus x to the power n, that becomes 1 plus x to the power n, which equals n, which equals nc naught plus nc1x, and goes up to ncrx to the power r, plus goes ncnx to the power n, right? So here the coefficient nc0, nc1, ncn of various power of x are called the binomial coefficients, right? Meaning nc0, nc1, and goes up to an ncn are binomial coefficients. Okay, let's copy down this. Okay, so now hence here we can write 1 plus x to the power n, which is your n, sorry, c naught, c1x, c2x square goes on, and cr x to the power r again goes on, plus cn x to the power n. This is your equation 1. So c naught equals 1, c1 is equals n, and c2 will become n into n minus 1 by 2 factorial. So cr is n into n minus 1 goes on n minus r plus 1 whole divided by r factorial. So that is equal, cn is equals to 1. right? Now we shall obtain some expressions involving these binomial coefficients. Okay, so one by one we will see. So first is sum of coefficients. Okay, so here putting x is equals to 1 in 1, so we get c naught plus c1 plus c2 and cn, which is 2 to the power n. This is your equation number 2, and that we can write it as r equals to 0 to n, and cr is equals to 2 to the power n. So this is for your sum of coefficients. Now if you go for sum of coefficients, wait for a minute, sum of coefficients with alternate signs, so in this, putting x is equals to minus 1 in 1, so we get c naught minus c1 plus c2 minus c3 plus and goes up to equals to 0. So this becomes your equation 3. So you can write it as r equals to 0 to n, and minus 1 to the power r and cr is equals to 0. Correct. So these are first two properties, sum of coefficients and sum of coefficients with their alternate signs. Okay, just copy down this and then we'll move to the next property. Okay, now next is sum of coefficients of even and the odd terms. Let me write it here. Sum of coefficients of even and odd terms. Okay, so from equation 3, from these previous property, we have c naught plus c2 plus c4 and goes on, which is equal c1 plus c3 plus c5 and goes on. So this as property 4. So that is sum of coefficients of even and odd terms are equals. Okay, so from 2 and 4, from 2 and 4, can write it as C naught plus C2 plus, which is equals C1 plus C3 and goes on. So that all becomes 2 to the power n minus of 1. 2 to the power n minus 1. Okay, wait for a minute. Your next thing is the sum of products of coefficients. Okay, so here replace x by 1 by x in the equation 1. So you will get 1 plus 1 by x to the power n is equals to c naught plus c1x plus c2 x square plus and goes on cn by x to the power n. So that's becoming your equation 5. Now multiply. Now multiply 1 by 5. Okay, so you will get it as 1 plus x to the power 2n power x to the power n, and that becomes c naught plus c1x plus c2x square, and this goes on, and again c naught plus c1 by x plus c2 by x square, and again this goes on. Now comparing the x to the power r on the both sides. Okay, so you will get it as c naught cr plus c1 cr plus 1, and this goes on, and that becomes cn minus r cn, which is equals to 2n cr minus of r, and that you can write it as 2n factorial and plus r factorial and minus r factorial. And this becomes your equation number 6. Okay, so just copy down this first. Okay. Next, sum of squares of coefficient. Next thing is sum of squares of coefficients. Okay. So in this, putting I equals to 0 in 6. So you'll get it as C0 square, C1 square plus C2, and this goes on Cn square. So that becomes 2n factorial by n factorial into n factorial. Okay. Next term is putting I equals to 1 in equation number 6, the previous one. So you will get it as C1 C0 C1 plus C1 C2 plus C2 C3 and goes on plus Cn minus 1 Cn. That becomes 2n Cn minus of 1. So finally it becomes 2n factorial and plus 1 factorial and minus of 1 factorial. So this is your equation number 7. Okay. Next thing, Z. If putting I equals to 2 in the sixth, okay, so what it will become? It will become C0 C2 plus C1 C3 plus C2 C4 goes on, and this is Cn minus 2 Cn, that is 2 and Cn minus of 2. So that becomes 2n factorial n plus 2 factorial n minus 2 factorial. So this is your equation number 8. Next, if we talk about next property, so differentiate both sides of equation 1. Okay, so that becomes n1 plus x n minus of 1 c1 plus 2cx plus 3c3x square and goes up to, and that becomes ncn x to the power n minus of 1. Correct. So next, putting x is equals to 1 and x is equals to minus of 1. So that becomes c1 plus 2c2 plus 3c3 and goes on, becomes ncn, that is n into 2 to the power n minus of 1. That's your equation number 9. And similarly, c1 minus 2c2 plus 3c3, that is equals to 0. That is your equation number 10. Okay, so we can write it as I equals to 0 to n minus 1 to the power n r, and c r is 0. Okay, now if you go for ith property, next one I, so adding uh, 2 and the ninth. So it will become C1 to C1 3C2 plus n plus 1 Cn, and here 2n minus 1 2n minus 1 and n plus of 2. So that's your property number 11. Sorry. Okay. So next is your zth property. Okay. So here integrating 1 with respect to x and between limits 0 and 1. So you will get it as 1 plus x n plus 1 divided by n plus 1, 0 to 1, and here c naught x, c1 x square by 2, c2 x cube by 3, and this goes on, and last term cn x n plus 1 divided by n plus 1, and limit is from 0 to 1, right? So that further we can write c naught plus c1 by 2 plus c2 by 3, and goes on. That becomes 2 n plus 1 n plus 1 n minus of 1. Okay, so this is your 12th. Okay, now last is integrate 1 with respect to x, and limits are minus 1 to 0. So in this you will get c naught minus c1 by 2 plus c2 by 3 minus c3 by 4, and goes on, minus 1 to the power n cn n plus 1, which is equals to 1 upon n plus of 1. So this is property 13. Okay, so you can copy down this. Okay, so some useful results are there. First is NCR is n into n minus 1 CR minus 1. Second, NCR, which is n by R, n minus of 1 CR minus 1. Third, 1 upon R plus 1 NCR, that becomes n plus of 1 n plus 1 CR plus 1. Next, fourth one is R square is R minus of 1 plus of R. And the last, rq, which is r of r minus 1, r minus 2 plus 3r, r minus 1 plus r. So these are the useful results. Okay. Okay. So next, let's look out at one example. AC naught plus a plus b c1 plus a plus 2b c2 and goes on a plus nb cn, which is equals to what? Okay. So solving a c naught plus c1 c2 goes on plus c of n plus b c1 plus 2c2 and goes up to ncn, right? So that becomes a 2 to the power n b dot n 2 to the power n minus of 1, that is equals to 2 to the power n. So 2a plus nb by 2, correct? So final answer 2a plus nb 2 n minus of 1. Can copy down results, and after that one example is there. So in today's session, we have seen the properties, okay, binomial coefficients and their properties. Okay, so first property was the sum of coefficients. Second is sum of coefficients with the alternate signs. Then even and odd terms. Then replacing property x by 1 by x, okay, which stands for the sum of products of coefficients. Then sum of squares of the coefficients. Okay, then putting that equals to 1 and r equals to 1 and r equals to 2. Okay, that property, and then differentiating property, and finalist is come integrating. Okay, while putting limits as 0 and 1 and minus 1 and 0, and some useful results which are shown here. Okay, you can check out. And at the last this we have taken one problem. Okay. Okay, so with this we are going to wind up the lecture here. Okay, so thank you guys, see you in the next class.